My name is Jason Fisher. I'm the Assistant District Engineer at the Dickinson District. And today I'm going to be discussing sign installation and inspection. And I'm by no means an expert in this subject, but I took a lot of time and reviewed the material available and combined it with experiences that I've had in the field and things that I've noticed in the field. And one of the things that I've noticed is that we spend a lot of time inspecting the bigger high dollar items like, paving, whether it be concrete or asphalt, but sometimes the incidental items like signing, lighting, guardrail, erosion control, and striping can be a little lax. And my hope with this training is to bring some awareness to some of the finer details in hopes that some inspectors with less experience can just realize how much detail there is when constructing these incidental items, and to remind those with more experience to maybe take another look and refresh what you think you know, and educate and direct your field crews to really dig into the details of what they're inspecting and to really study the specifications and standards so that they can achieve quality work in the field. So before I dive into the signing installation, I want to just kind of have a short safety discussion. We often hear that safety is a culture, and I truly believe that. And in our district, we've implemented what we call operational safety talks. And these are short discussions that our crews, whether it be maintenance or construction, have prior to going out in the field and completing a task. On our construction sites, there are many dangers, so it's important that everyone on the crew communicates well and understands the chain of command and who's in charge. The person in charge needs to communicate with the crews, the important safety information so that everyone on the project can stay safe. And this can include where to park, where to walk, what to look out for, what dangers are potentially present, and what safety gear might be needed. Make sure you're reminding them to always make eye contact with operators before entering their area. Remind them to stay out of the way of the contractor, but at the same time, make sure that they can still do their job effectively. And these small daily reminders, may save a life. And if we can just get that as, part of our normal practice every day, I think that message really gets driven home. So when I first started with the DOT about 20 years ago, our construction office had more employees. We had a wealth of experience. We had people on projects, a lot more people on projects available to inspect. Typically, each inspector, had assigned items that they were responsible for, and we really didn't have consultants doing construction projects for us. 30 to 40 years ago, so I've been told, that inspectors were even assigned to individual pieces of equipment because there was enough people. But for sure, there was an inspector available and assigned to each individual crew. But now things are a little different. We have less people available, and the people that we have are not only assigned to multiple operations and crews, but they might even be assigned to multiple projects at the same time. The wealth of knowledge is shrinking. And those old interstate guys, that, started everything and taught everybody everything, they all retired. The old construction manual, that literally taught you and told you how to do everything is, all but disappeared. And if you don't know what the construction manual is, you can just go down in your district basement and poke around until you find an old yellow binder and just start reading it. I mean, that wasn't there's a lot of new faces. There's a wide range of knowledge, and somehow the experiences that we all have need to get passed down from one person to the next. So as a result of this, I think a lot of focus is placed on the larger items in the field, and the smaller ones, such as signs, are not getting inspected probably the way they should be, and we might be missing some of those details in the field. This can really get frustrating for the sign installer, the DOT sign shops, just any owner, because, when things are done wrong, it costs us time and money. In fact, I've read a few diaries where it says that, something in a diary will say something like the signing crew never called and told us they were coming out on the job. So we drove through the job today and all the signs were up. So when I see these kinds of things, it really bothers me because there are just so many things that I have found wrong with signing and so many details that need to be looked at. So today I'm going to look at 3 different types of sign installations that will be and those are perforated tube, round steel pipe, and W-shaped signs. These all have different standards and requirements to follow for correct installation. The pictures there just show the different types of sign supports. Round pipe and W-beam signs are typically used for larger signs and higher speeds, like on the interstate, where perforated tube is more of the standard that we use on our rural state highways. So first, I just kind of want to take a look at our specifications. 754 is the specification for signing. It's a good idea, anytime you go out to inspect an item, to read your specs. Just read it, read the whole section. Don't just look for things that you think you remember or something that you want to look up. Read the whole thing and just refresh yourself so that you know what's going on out there. But anyway, the first spec, 75404A, states that signs 30 feet or more from the edge of the road should be 90 degrees from the road or to the road. And signs 30 feet, less than 30 feet from the edge are 93 degrees away from the road. So if most of your signs will be angled slightly away from the road. And that's important so that the signs don't reflect back and blind the driver. There's a road going out to our farm and the county put the signs on and they're actually angled a little bit toward the road, and that is really annoying and really blinding. So just something to be aware of and pay attention to. The next part of the spec, 75404B, talks about making sure that there's an appropriate label on the back of the sign so that we know when it was fabricated. We've been getting a lot of signs lately with no fabrication date on the back of them, and we have to have them come back in and put those stickers on. So something to really watch for. I don't know if they're not putting them on when they manufacture them or what, but it's just really happened in the last couple of years. It's important because our maintenance people need to know that, how old they are, because those signs need to be replaced every 10 years. The next spec, 75404D1, talks about erecting sign supports. And the first part of the spec is it instructs the contractor to confirm the length of the sign support with the engineer. So the contractor has the right to ask the engineer for the lengths of the supports according to our spec. And this generally only happens on round pipe and W-shaped signs, since those supports are fabricated in the shop. For perforated tube is generally field cut, so it isn't as critical, but we'll kind of get into more of that later. Next part is to construct concrete foundations with the top sloped away from the sign support. And this seems pretty obvious, but I've seen several of these where they finish around the stub pipe and end up with the concrete settling right there, and it just allows a spot for it to hold water, and it causes it to prematurely rust out or whatever. And then the last part of that spec is to use the same breakaway base system through the whole contract, which is important for our maintenance guys so they don't have to have so many different types of bases around, and they know what to take out to particular jobs. 75404D2 talks about anchor for perforated tubes, and it says to drive the anchors so they're a max of 4 inches above the ground. This is repeated in just about every standard drawing. If it's more than 4 inches out, it becomes a hazard. We also got to make sure that these bases aren't buried. So if they're, a breakaway base and they're buried in the ground, they're not going to break away and perform the way that they're intended to. So it's pretty important. It's an error I have seen, repeatedly, many times, especially if the signs are put up before the topsoil is all the way finished. So really watch out for that. And the spec also talks about Coring concrete or bituminous material before installing the anchor and fill the cored area with like material. So here's a few pictures of some of these. Here's a sign that was installed, that wasn't cored correctly and it spalled out. And obviously the hole wasn't filled back in with concrete. Here's another one where they put a sleeve in there instead of coring it, but then they didn't cut the sleeve off and they didn't fill it with concrete. Here's one they actually did fill with concrete, but the breakaway base is over 4 inches high. So that sign had to be cut back out of there and redone, pounded down. And here's one that we found that was buried. Again, if a breakaway base is buried like this, there's no way it can function properly. So just things to be aware of. 754 04D3 talks about tubular sign supports. So set tubular signs in concrete foundation and place the plates so the tapered bolt slot tapers towards the approaching traffic. So just reading this spec is a little confusing without looking at the standard, and what this is referring to is the base plate of the breakaway base used on round pipe and W-beam installations. And this is what they're talking about. So if you look here, there's on the breakaway base plate, these holes are slotted and angled, and this angle has to face the road on the approach side. So I think they do that so that when that sign breaks away, that it pushes out away from traffic and not into the roadway. So chances are they've got this manufacturing process down pretty good, but once you put a sign in the median, that plate would have to be flipped the other way. So, and manufactured the opposite direction. So really pay attention to this if you ever have a sign on a 4-lane road, where you're putting it on the median side. The next spec talks about W-shaped supports. First thing it says is the bolts need to be torqued. I don't know if I've ever seen a diary entry where I've seen somebody record that these bolts are being torqued on these signs. I think over torquing the bolt could cause it to not break away. I think under torquing it could cause it to loosen up. So the spec talks about it, so I definitely think that we should do it. And of course, there's the same note for W-beam as there is for the round pipe, talking about that angle being towards the road for approaching traffic. This is the table from standard drawing 754-14 that shows the different torque specs for the different size bolts. Next spec talks about mounting flat sheets for signs, and the specification says that we need a nylon washer between the flat washer and the sign face. In this picture, you can see where the nylon washer is installed. I've seen signs where this has been omitted, and so I just want to draw attention to it. The next spec talks about removing and resetting signs. So on construction projects, signs should get stockpiled on the project, and then the district picks them up unless, some other arrangements are made. They're not the property of the contractor like most of our removed materials. There's been a lot of times where contractor just pulls them out, loads them up on their trailer and takes them back. And sometimes they even pick up the signs that were supposed to be reset and haul them back just because they didn't know. So it's important to have these conversations ahead of time so that, the removed signs are stockpiled where they're supposed to be and any reset signs are taken care of. The next part of the spec talks about removing signs and supports as construction progresses and immediately reset or install new signs. You can't just take your signs down and leave them down if you have a grading project. If you take nothing else away from this presentation, just remember this part. Signing on the roadway is there for a reason, and we need to make sure they're there for the traveling public. There could be some signs that we can take down and leave down, maybe like an adopt a highway sign or something like that. But the majority of the signs are there to let the traveling public know where they're going and to communicate, essential safety messages. And finally, it talks about that the engineer will allow temporary reset of existing signs or the temporary installation of new signs. And the cost of that is all included in other items. So the contractors are supposed to be doing this, and it's at their cost. This is just a great example of a sign that needs to stay up. We had a sliver grading job last year, and we worked around this sign all year and reset it a couple of times. I just don't want to be the guy sitting on the stand in the courtroom if somebody was to go off this curve and I was the one that chose to allow this sign to stay down. 750-404F talks about removing and resetting sign panels. Now, the thing I encourage here is to make sure to take an inventory of those signs so that, if they're shot up or they're too old or whatever, don't reset them, get new ones. And then just make sure that where they're being stored so they don't get lost. And that they're taken care of. We don't want these reset signs laying in the grass and getting wrecked or ran over. So here's an example of a couple of signs that we were supposed to reset. We got out there right away on the job and inventoried our signs. The sign on the left obviously was shot up, and the sign on the right was over 10 years old. And this age thing, I think, is getting to be more important to check because we got, what they call shelf-ready plans now. So we might have plans that are ready 2 or 3 years before they go out to bid. And so those signs that were okay to reset then probably aren't now. So we also have a lot of jobs that get pushed from year to year, so that could move some of them out as well. So just make sure you have the conversation again about who's responsible for these signs if they are in good enough shape, and take pictures of them so that when it comes to the end of the year and the contractor was supposed to take care of them and they didn't, that you have some documentation of that. And lastly, the spec talks about method of measurement. That flat sheet sign panels are measured to the 1/10 of a foot, and rejected a lot of PQEs because people just round these to whole numbers. That's not correct. Talks about engineer measuring post lengths, then that it includes the length of the anchor. Seen many times where posts are measured and paid for, but they forget to include the anchor. Talks about the quantity of concrete for foundations for round pipe. Get paid as at the planned quantity, not off the ticketed amount. Resetting sign panels. If you have a reset sign panel where it's a one assembly and it has 2 or 3 signs on it, that's still just one reset sign panel. Conversely, if you're doing a reset support, each leg of the support is considered a reset. So if you have a single sign that has 3 legs to it or 3 supports, that would be paid as 3 each. So good idea to review this in the PS&E plans to just make sure that the designer is doing this correctly so there's no confusion in the field. So in the next segment of the presentation, I want to cover kind of what's in the plans, how to stake the signs, and how to determine the horizontal and vertical clearances, and then how to calculate post lengths. We see a lot of errors in the field of, that signs are just put in the wrong spot or at the wrong height. So I just want to review that. So first thing, generally in section 110 of the plans, you'll have your sign summary sheet that, has all the signing details. Like I say, it's usually the first sheet, gives you the location, the assembly number, which is important so you can correlate to the proper standard drawing, has your sheeting type, assumed post lengths, your vertical clearance, support size and gauge, the max post length, whether it has a sleeve or not and what length that is. Gives you the type and size of anchor and if a breakaway support is needed. And it's just a good idea to review the sign summary sheet and make sure it correlates with the standard drawings. I found a handful of errors in these where where breakaway bases were missed or where vertical clearances were wrong. So it's a good idea to review this, and if something doesn't look right, don't be afraid to ask the question. So the next sheets will probably be layout sheets or a plan view where the signs are actually located in the field, but you can just be aware that, this is just a visual of the sign and the station. Most of what you need to know is going to come from the standard drawings and special assembly sheets. So after reviewing the plans and gathering the information that you need, then it's time to kind of go out to the field and mark the locations for the signs. And need to check the support lengths and make sure that what's in the plans is reasonable. You also want to talk to the contractor before you begin any staking and agree on a plan. Does the contractor want you to stake the center of the sign? Does he want the exact, location of each post? Does he want the post, but he wants them a foot offset? A good communication with the contractor and a plan, getting a plan together is definitely the first thing to do, because the last thing you want to do is stake an approximate location and then the contractor's new guy comes out and pounds all the anchors right where your lath was and it wasn't where you wanted the sign. When it comes to stake signs, you don't need to power for the most sophisticated survey equipment in the world. You just need a basic, a DMI or a wheel, measuring tape, paint, lath, and make sure that you have the plans and all the standards with you, because there's just a lot there. And I really encourage you, when you go out to stake signs, to look at that stuff ahead of time where you're, at a desk and fill out a field book, make a field book for each sign so you can get these things right. So let's kind of focus on this first line of the sign summary sheet. Shows the station of the sign, which side of the road, and it also has that sign number or assembly number. Tells you what kind of sheeting, what size it is, and how many supports. Remember, those support lengths, those are estimated lengths. That's what the designer thinks it's going to be. And just keep in mind here, like for this sign, the support length for that second post is 10.4 feet. Moving across the page, again, we have the vertical clearance and then the support size, which is a 2.5 by 10 gauge. And that max post length on this particular sign is 10.9. Remember from the previous sign that the post length they think it's going to take is 10.4. So this particular sign is really close to what the maximum post length is. So it's definitely a candidate for one that we should, check the post length on in the field and make sure that, we're not exceeding that max post length. Because if you do, you'll have to go to a larger tube, and if that happens, just contact the designer and get the next size post length for that. The other thing to notice here is that 2.5-inch Telespar or perforated tube comes in. We use both 10 gauge and 12 gauge. So it's really important to make sure that they don't grab the wrong size support off the truck and that you're checking the gauge of that tube. And then continuing across the page, you can see that this sign requires 2 anchors, one for each post. They're 4 feet in length. It's a 3-inch square anchor and it's 7 gauge. So knowing that off of that sheet that this sign number is 28, you can look further down in your drawings and find the details for this sign. And the detail for the sign, it shows all the dimensions of the sign. It gives you the dimensions of every letter, of all the graphics. Don't take for granted that the signs were made correctly. You should check the lettering heights and widths. The vertical location of the lettering is actually dimensioned on the sign, and the horizontal dimensions, or in the X direction, is actually in that table towards the bottom, and that's measured from the left edge of the sign in inches. Couple examples. This is a job from a couple years ago. What you see here on this picture is the plan view, which is like the black lettering overlaid with a photo overlaid on it of the actual sign, and you can see that the word Killdeer and the word Beulah had the wrong letter spacing. Same job, different sign, kind of the same issue. You can see that the letter spacing was incorrect. They were too tight together, and so those signs actually had to be removed and replaced. So it does happen. I'm not saying it happens all the time, but it is a good thing to check. And it's good to check them when the signs come out. You know, when them signs are 16 feet up in the air and you're trying to measure this on a ladder, it gets pretty tough. So after looking through the plans, you know where the signs to be located, you know, and the sign size and how many posts are required and all that. We need to kind of dive into the standard drawings to see, you know, where the sign is supposed to be placed. If you're looking at perforated tube, the drawing you want to look at is 75423. I'm kind of diving into this detail a little bit closer. You know, we know that the sign is to be located at a certain station, and it's a 2-post sign, and it has a vertical clearance of 5 feet. Since there's no curb, you know, for this particular sign, we look at the horizontal clearance table. And to know what your horizontal offset is, you need to know what your finished shoulder width is at the location. So once you have that shoulder width, you can figure out what the correct clearance is to the edge of the sign panel. That's where the clearance is measured from, is the edge of the sign, not to the post. So here's where it's really helpful to talk to the contractor to make sure that you guys are on the same page with what you're staking. So for this exercise that we're going to do here, we're going to assume that the contractor wants the sign posts themselves staked, and we will assume the finished shoulder is 9 feet. So if you remember, you know, the sign detail said that it required 2 supports, but it didn't give us the location of those supports. So we gotta look at another drawing to figure that out. So again, here's the sign that we're talking about. It's 3.5 feet high and 6 feet wide. You know, so now we need to find that particular size sign in our assemblies. And there's like 50 some of these standard drawings. So it's kind of cumbersome to find them sometimes, but something that we have to do. It's 75448, shows the stringers and the supports for this particular sign. Zooming in on this, you can see this is a 3x6 sign, and it tells you that we have an overhang of 1.5 feet and post spacing of 3 feet. So in this slide, you know, it just kind of shows that calculation. So to get the horizontal distance to the first post, you need to add the horizontal offset to the overhang dimension. So that comes out to 25.5 feet. And then of course the next post over is 3 feet from that. So by doing this, you'll ensure to have the proper offset. You can do it at this time when you're staking signs, or you can do it at the end when you're checking signs, but either way it has to be done. So in my opinion, just stake the sign where the post goes so that there's no confusion, and we get the sign where we want it. This slide here is just kind of a review on how to stake the sign posts in the field. You know, use a DMI or a wheel to get to the correct station. Use 75423 to figure out your offset. Use your plan sheet to look up the sign assembly. Go through and find the correct standard drawing to get your sign overhang and your post spacing, and then add the overhang to the horizontal clearance, and that's where your post would go. So now you need to calculate the post length needed, and this is usually not an issue on perforated tubes since it's usually field cut, but for W-beam and round tubes, those are manufactured to a specific length. And so the contractor will be asking you for those sign lengths. I've seen numerous errors on post lengths, and those are very costly because you know, this is a large amount of steel that we're talking about. The vertical clearance is measured from the edge of the traveled lane to the bottom of the sign panel. So again, that vertical clearance can be found in the sign summary sheet, and it's also on the standard drawings. It's usually 5 or 7 feet. There's notes on the standard drawing that talk about the vertical clearance. Like I say, most of the time it's 5, but there are some instances like where there's pedestrian movements, or if there's you know, a parking lane where them signs need to be 7 feet. And this is where in the standard or in the sign summary sheet, once in a while mistakes are made. So just make sure that you're paying attention to that. There's also a note that talks about that the maximum vertical clearance is 6 inches above the minimum. So there's not a lot of room here for error. So to figure out the correct post length that you need, you'll need to get elevation shots at the edge of the driving lane, you know, with a rod and level or GPS, and at the location of the first and second post. Just as a reminder, if your inslope is going to change, like on a grading job, you need to account for that difference for the cut and fill in your calculation. To determine that elevation difference from the edge of the lane to the top of the ground, where the post will be installed, you need to set up a level and take a rod reading at the edge of the lane, and then a rod reading where you stake the sign. You can also get these elevations with the GPS or something as well. And then once you get those field shots, the math is actually pretty simple. Calculate the difference in the rod readings from the edge line to where your lath is that you staked, and then add that number to the vertical clearance, and then add in the height of your sign, and that'll be your post length. And again, once you get that post length, you need to make sure that it didn't exceed the max post height shown in your sign summary sheet. Here's kind of a summary of calculating post lengths. You know, first determine that station and horizontal location, then determine the elevation difference between the edge of the lane to the top of the ground where the post will be installed. Add your vertical clearance, which is 5 or 7 feet, and then add the height of the sign panel. And just as a little side note, you know, we have that additional 6 inches above the minimum for our vertical clearance. So the height of the base, which should be 4 inches or less above the ground, that'll use up a little bit of that distance. And, you know, therefore it doesn't really need to be accounted for when determining your post length. So if you set stuff for 5 feet and that anchors out of the ground 4 inches, you'll have, you know, your bottom of your sign will be at 5 foot 4 inches, and that's perfectly acceptable. Again, you want to pay special attention on any grading project. If you have a little cut fill in the ditch, you want to review your cross sections and make sure that you're accounting for that change. After your signs are installed, it's important to check the vertical clearance. Easiest way I found is a simple hand level. You can just stand on the edge line and hold that hand level at 5 feet by sliding it up or down along the rod and shoot the sign. If the bottom of the sign is between 5 and 5.5 feet, you're good to go. Another way is to use a rod and level. This slide just kind of gives you the instructions on how to do that. Take a shot on the edge line, then you can invert your rod and put it on the bottom of the sign and add those two together to get your vertical clearance. Now I want to move into some specifics on just perforated tube, and the slide here kind of shows you where to get that information. First thing that we'll do is install the anchor. You know, when you install an anchor, we got to check, you know, if it's a standard mount or breakaway, is it level and in the correct location? Is it angled slightly away from traffic? Is it the correct orientation? Does it meet the applicable standard drawing? And is it pounded down far enough? First standard I want to look at is 75424. It shows all the mounting details for perforated tube. And in the following slides, we're going to look at just portions of this standard drawing. There's just a ton of information here, and it's really hard to pick out everything in these standards. First off, standard drawing has a table of the different tube sizes and gauge thicknesses and whether or not a breakaway base is required for certain tubes. Again, it's important to check this against the sign summaries and make sure that the designer didn't make a mistake. Notice that 2.5-inch tube comes in both 10 and 12 gauge thicknesses, so it'd be really easy for that contractor to grab the wrong size of tube, which would affect how that sign's going to perform. So when a sign or anchor is installed, you should be verifying that the correct size and gauge is being used. To know the gauge thickness, you can use a caliper or that gauge. If you look on the bottom right picture, you can see that the gauge of the metal is actually stamped into the telespar, but it's tough to find sometimes. This standard drawing just shows a breakaway coupler system. Again, it shows here that slip base has to be 4 inches max from the ground. Basically, that's a requirement for any of these installations. This drawing shows the details of the breakaway base that's typically used. Note that those Teflon coated slip washers, I've seen contractors try to use regular washers because they ran out. Also, I want you to note the orientation of the slip base to the traffic flow. There should be washers on the top and the bottom of that plate, and make sure they're using the right size of washers. We had an instance up in where we installed some light poles and the contractor used the wrong size washer when they mounted that, and those washers actually pulled through and those poles almost tipped over. Kind of a scary thing. I guarantee you now we measure our washers. So something that probably isn't done very often, but it's a very important part. And also notice that locking wedge over here. Make sure when they put those in that they're pounded in and they're tight. This is what a breakaway base would look like. Here you can see one that's installed correctly on the left, and on the right you can see that the slip washers are not the correct washer in the middle there, and also this one is too tall. So just as an example, here we have a drawing of a surface mount breakaway. I've had good luck with these in concrete, but I wouldn't suggest using them in asphalt. The ones I've tried to put in asphalt, they've loosened up over time, and we've had to do something different. This standard here, 75425, shows the mounting details for the stringers and the sign panels themselves. Again, a lot of information. Just some things I want to kind of point out again are the nylon washer that needs to be installed against the sign face. And also the notes, especially note 3 that talks specifically about no parking signs and how they're angled versus other signs. And this is different from what our spec says and what, how any other sign is done. So just if you have no parking signs, those are at a different angle to the road. Here's a picture of a sign again. This detail here shows to use a 3/8-inch bolt with a washer and lock washer. And when I look at the picture, I only see a lock washer. So I got to check with someone. I don't know if this is wrong or if that note's actually referring to the nylon washer, but it's just something that, when we look at the details, we need to question these things and make sure that we're putting them in right. Here's another drawing of an anchor. You can see again the 4-inch max above the ground and the bolts that are supposed to be used. If you look here, this sign installation detail shows both bolts go in the same direction. Whereas the way this sign is installed, you have a bolt going in each direction. So again, I'm not sure if this is right or wrong, but as inspectors, these are the things that we need to be questioning and making sure we're installing right. If we have questions, you know, we have experts that we can ask. I'm probably not that guy, obviously, but you know, Daryl or somebody else maybe can answer some of these questions. Okay, that same standard also shows the wall thicknesses for the different gauges of perforated tube. So again, this needs to be checked in the field. You can see here that, you know, we're using a caliper here to check the gauge thickness, and that's obviously going to be a 12 gauge tube. So once the sign is installed and verified to be correct, you need to measure and pay for it. And standard drawings show these pay links. So notice that on the left side here, if you have a standard anchor, the pay length includes this 6 inches of overlap plus the anchor. If you have a breakaway, you can see the pay length doesn't include that overlap. So I don't know why that is or whatever, but that's the way it's laid out. So just make sure that you're measuring these right. I find errors all the time in how signing was measured, and make sure you're measuring them yourself and not just taking the contractor's word for what's out there. Next few slides, we'll talk about round steel pipe. That's the information on where to find that stuff. Big difference with the round pipe is that we put them in a concrete foundation. So you'll need to know what kind of breakaway base and look at some foundation details for those signs. 754-1 is very similar to the other one we looked at. I'm not going to really review this. 754-3 shows the different breakaway bases. Zooming in on that, you can see there's different bases with different angles if you have a single post or multiple posts. Also has this direction of travel, which is very important. You want to make sure the low side is facing oncoming traffic. Notice in the fine print in the notes about the keeper plate being installed above the washer and the importance of removing the galvanization runs in the washer area above the stub project, you know, on that stub pipe. I think this is important so that the torque of the bolt is right and that plate is able to slide if it ever gets hit. So these little things should all be checked when we're installing these signs. This drawing here details the base plate. Again, that bevel or angled hole needs to point toward the roadway for oncoming traffic. Also notice that they have the shim detail and that keeper plate detail and where that keeper plate is installed. And then there's also torque values here, again, for these bolts. So notice these are pretty low torque values. 29 foot-pounds, that's not a lot. So we got to make sure we're not over tightening these, and we got to make sure we're not under tightening these so that these things perform correctly. There's an assembly procedure for round pipe, and I don't know if I knew that these were even here, but check these out. Talks about the washers. It says to shim as required. It tells you, you know, to tighten the bolts first with a wrench just to seat them and clean the threads, and then retighten the bolts to the prescribed torque. And then we're supposed to loosen the bolts and fill the gaps between the thread and mating surface with thread locking resin. And then retighten the bolts to the torque again. I'm not sure if this is being done or not. Like I say, again, I've never seen that procedure detailed out in anybody's diary. So might be worth some questions if this is what we want to be doing. Maybe something has to be revised, but if not, we should be enforcing this in the field. This is not the proper way to shim a sign. I know the note says shim to plumb, but I don't think this is what they had in mind. And yes, this actually happened. This is a picture of an installed sign. Looks to be pretty much correct. 754-5 talks about the foundations. A zoomed in version of this shows the different reinforcing steel for the different diameters of the foundations and depths. 754-6 details out your hinge plates and fuse plates on these signs, and also has some foundation details. Zooming in on this, notice that the hinge plate has specific size and dimension, and that hinge plate goes on the side opposite the sign panel. The fuse plate has holes in the middle of it to weaken it. And these holes need to be in the correct location and size so they break away correctly. So check it. Don't assume the contractor grabbed the right plate off the truck. I have seen errors where they've put the fuse plate and hinge plates on the wrong sides of the sign. They mix them up. So watch for that. This drawing here shows your rebar cage in conjunction with that previous standard I showed. You need to make sure that the rebar is checked and correct before they put it in the hole. So we're almost getting to the end. The last part I want to talk about is just the W-shaped sign installations. A lot of this is very similar to the pipe, but again, 754-13 has just an incredible amount of drawings and detail, and it takes a lot of time and a lot of studying to make sure you catch all of these things. Again, the breakaway base for the W shape is similar to the round pipe. That bevel needs to be installed the right direction so it breaks away correctly. If you need to put it on the median side, again, that plate's going to have to be reversed, so really keep an eye out for that. Again, hinge plate and fuse plate details, very important. They need to be checked. Here's what those look like installed. Your hinge plate goes on the back side right here, and your fuse plate that has the weakened plane, the holes in it, that goes on the panel side. So check and make sure that that's getting done correctly. Again, there's an assembly procedure. Assemble the base plates with the flat washer and the keeper plate. Shim as required to plumb the post. Again, you got to tighten with a wrench to clean the threads, then loosen and retighten to the prescribed torque. And then talks about assembling those fuse and hinge plates with a washer and lock washer. So pay attention to those notes. Again, here's your torque values. These ones are in inch pounds, but still, 60 inch pounds is what, 50 foot-pounds. So again, it's not a lot of torque. I think it's important to make sure that we're actually torquing those the way they show them here, so they perform right. Again, don't shim like this either. I don't think this is what they had in mind. So this is what an assembled base would look like. Notice the washer above and below and in the middle on the plate, and you can see the keeper plate right down here. Here again, another good view of the washers. Here's that brass shim. And then your keeper plate is installed above the washer the way it's supposed to be on this one. This picture shows a breakaway base system for a W beam installed. Notice that the slit base is less than 4 inches above the ground the way it's supposed to be. 754-14 shows the wind beam details. These are also important to make sure they're installed correctly and in the right location so that the wind doesn't affect these signs. Just a little blowed up version of that. And here's what the wind beams look like on the back of a panel sign with W beam. So in summary, there's a lot of different details to pay attention to when installing signs. It's really important to study these standard drawings. Make sure to review your specs every time you inspect. Now, if something doesn't make sense, ask questions. Be careful and accurate when calculating post lengths and locations. Document what you inspect, measure and pay timely and accurately, and communicate effectively with your contractor so you're on the same page. This last picture again, just to kind of reinforce how important these little details are. This is one of those light poles where they used the wrong size of washer, and you can see the washer ended up, failing and falling inside and loosening that whole base up. So these things are important. It's happened where things get messed up, and I just can't encourage you guys enough to, take the time to really look at those details. With that, I hope this was helpful. I know I went over a time a little bit, but it's crazy that I can talk about signs for an hour, but really I probably could have talked about this for 2 hours to get through, or probably 2 weeks to get through every detail, but there's just a lot of stuff there. So just don't send the intern out there that has no experience and say, watch, just go watch them put up signs. We really got to make sure we're training these people that go out and that we're doing a good job of inspecting these, because it is a safety issue, and there's a lot of detail there. So, and with that, I can take a question if anybody has one.
I'm going to talk about cement treated base. Now, this is probably a timely topic to talk about. I know in our district we have a cement treated base project coming up that's going to start this summer, and probably sooner than later given the weather we have out here. But I know there's a few other districts, I believe, that have some cement treated base projects coming up. So I thought maybe we would just dive into the SP a little bit. I'm going to talk about my project a little bit, and at the end, if we have any questions or discussions, we can talk then. So first off, what is cement treated base? Cement treated base is a type of soil cement describing an intimate mixture of native soils and or manufactured aggregates with measured amounts of Portland or blended cement and water that hardens after compaction and curing to form a strong, durable, frost-resistant paving material. Now that's kind of a mouthful, but really what it is, we're just adding cement to either the base or the sub base, whatever we have in place in the field. The picture I've got up here is actually a completed cement treated base we have in our district. That was placed probably like in 2008 or 2009. And this is exposed because, and I'll talk about this a little later in the presentation, but we came back in and replaced a bridge, and we had to do our tie-ins at the end of the bridges. So we exposed the existing cement treated base out there. Some advantages of cement treated base and why we use it. It provides a stiffer, stronger base than an unbound granular base. The picture on the left there, you can see the two different scenarios between an unstabilized base and a cement stabilized. The cement stabilized gives us a stiffer base, which reduces deflections from traffic loads. And by reducing deflections, of course, that will reduce the strain and ultimately lower distresses in our surfacing and hopefully extend the life of our pavements. Another advantage is you don't need as the same amount of thickness in the cement treated base as you would with an unstabilized granular base to carry the same traffic load. Again, the pictures on the left here, you can see in a cement treated base, it distributes the load over a bigger area because it essentially acts like a slab as opposed to more of a point loading where there's an unstabilized granular base. Other advantages of a cement treated base is it could potentially increase, or it could you can progress more quickly in a using a cement treated base just because you have to keep a tight train, so to speak, between applying the cement, blending, compacting, shaping. You really have a tight window to get that done. So construction seems to progress more quickly sometimes. Another thing, an advantage is, and you can see in the picture on the left, and this follows some of the previous slides, but it distributes the load over a wider area as opposed to an unstabilized base, more of a point loading. Another potential advantage could be cost savings. Depending on the location of your project, the availability of aggregates, all kinds of different things. If you can just add cement to what you have in place or existing, it could eliminate, one, purchasing aggregates, and two, hauling them all the way to your project site. So there are some potential cost savings with using a cement treated base. So now I'm just gonna kind of go step by step through our special provision that we have on our cement stabilized projects. So this is the typical SP you'll see. If you have a cement treated base project, this is most likely the SP you'll see. So just to walk through this, the first part of the SP gives you the description, which we already talked about. And the next part of the SP talks about equipment. Pneumatic tired rollers, vibratory sheep's foot, 12-ton steel wheel, water truck, cement truck, and the mining and blending machine. So I know probably all of you on here know what this equipment is and what it looks like, but just to talk about it a little bit, pneumatic tired roller. You'll basically see one of these two types on your project. You got a tow type on the left, and you got a self-propelled on the right. Now, one thing you should do, which a lot of people don't do, including me, is go into our spec book. So this equipment is found in section 151 of the spec book. And I'm not going to go through the specifics in there, but what it does is it talks about what these rollers have to have. It talks about the amount of tires. It talks about the weight. It talks about the PSI in the tires. These are all things that, we should check on not only this type of project, but every type of project. The next type of equipment that talks about is a vibratory sheep's foot. Again, this can be found in section 151 of the spec book, and that talks about, the weight of the piece of equipment, the width, stuff like that. Vibratory sheep's foot, I'm sure, like I said, most of you have probably seen it, but it's just a padded foot compactor. The next piece of equipment the SP talks about is the steel wheel vibratory roller. Now, in our particular case, we're going to use this piece of equipment when it comes to microcracking, and that's something we'll talk about later in this presentation. But that's mainly what we're going to use this piece of equipment for. The next piece of equipment talks about is the cement truck. Now, here's a picture of a cement truck driving down the project site. You can see he's applying the cement to the road surface. Now, these cement trucks are calibrated to the mix design to make sure that we get the correct amount of cement applied to the road surface. Now, in this picture, you can see there's some dust coming up from the back of it, which I don't think there's a lot in this particular case. But another option is to put a skirt around the outside of it. And what that does is it keeps the right amount of cement being applied to the road, and it keeps it from blowing away. I've got a short video here, and I'm going to talk while this is going on. main point of the video I'm trying to show here is just to show it in action, mainly the speed that it's operating at. And now, and speaking of the speed, all that should be calibrated in the truck, because obviously if the truck drives faster or slower, you'll want to make sure that the cement getting applied to the road still gets applied correctly. So in this particular case, you can see it's got the skirt on the outside, which I think is good because it keeps wind from affecting it. It keeps, any of the stuff from blowing away, and making sure that we get the right amount of cement applied to the road surface according to the mix design. You see on the left-hand side of that, there's a little bit of dust coming out, but it's not bad at all. So all the cement's getting applied as we had wanted to. And then the last piece of equipment they talk about is the mining and blending machine and the water truck. So in this particular picture, you can see the mining and blending machine and the water truck, which happens to be connected to the mining and blending machine with the hose. So the hose is obviously supplying water from the water truck to the blending machine. And according to the SP, we want to make sure that water gets injected directly into the cutting and mixing drum in that machine. So the correct amount of water can get added according to the mix design, so that we get the product as close to the mix design as we can. And this is just another picture of mining and blend machine hooked up again to the water truck. You can see the cement's already been applied to the road surface, and they're just doing the blending as they go. This is just a really short video of the blending machine in action. You can see the cement's already been applied to the surface, just to give you an idea of speed. So that's a quick overview of the equipment that you should expect to see on this type of project. The next page of the SP is the mix design. Now, the mix design, what we're looking to achieve in the mix design is we want to develop a mix design that achieves approximately 300 PSI strength at 7 days. And the SP talks you kind of through how you do that, but it's important. To me, the biggest thing you want to watch for when you do the mix design is when you get your sample to run your mix design, is you want to make sure that the sample is as representative as possible of what you actually have on site. I mean, which I know that's probably obvious to most people, but everything's going to be based off this mix design. So you want to make sure it's as good as you can get it. So what you're going to do is go out, obtain your sample. And the first thing you need to do is determine the optimum moisture content and the maximum density of the material in place. Because the moisture content is probably the most important thing to know here. So what I've got here is an example of a mix design. I actually pulled it off of a Dickinson District project, but this is the first part of the mix design, is determining the optimum moisture content and the maximum density of the base. And in this particular case, you can see that the maximum dry unit weight is about 124 and the optimum water content is 7.8%. And they did this using test procedure AASHTO T99. Once you have that, then you can generate a cement content curve. And here's an example of that curve. So basically, how you do that is you want to use different amounts of cement with the sample you have, mixing your samples up at the You want to make sure that you're at optimum moisture content or 2%, 2 percentage points above that to develop your curve. So when you mix your samples together, you let them cure for 7 days, then you break them, see what kind of strength you have. You plot those cement contents on a curve against strength at 7 days, and the mix design says we're looking for 300 psi at 7 days. So you simply follow 300 psi on the curve you created and follow it down. And according to this chart, the cement content for our mix design is 4% cement. So that's what's going to go into the project is 4% cement. But our mix design goes on to ask for some more information. So the information we need in the mix design is, number one, you need to make sure that there are 2 points on both sides of the 300 psi. And in this particular case, we do have those 2 points on both sides. We have a point at 2.5%, 3.5% on the left side, and then we actually have 3 points on the right side, 4.5%, 5.5%, and 6.5%. Another thing that the mix design or the SP requires is plots of compressive strengths at 1.5% above and below the recommended percentage of cement. So at a recommended cement content of 4%, we would need a point at 2.5% and 5.5%, which we do in this case. Another thing that the SP requires is to show compressive strengths at the mix design cement content of 4% at 1, 3, 5, and 7 days. So in the mix design, you can see we have that listed as well. So this mix design covers everything that we have in the SP. So that's how we develop the amount of cement. The next thing the SP talks about is application and blending. Now, there are a few restrictions when it comes to application and blending. I think they're for obvious reasons. Number one, the roadway shall not be frozen, which obviously we don't want that. And then there is a temperature spec on it. We want it basically 40 degrees and rising. We want to make sure that we don't get down below that 40 degree temperature mark. You don't want to apply on ponded water or during a rain event or when rain's imminent. I mean, obviously, because that's going to add water to our material, and then that pretty much throws the mix design out the window, and it's not what we're basing our design on. And another restriction we would have is don't apply when the wind speed's 20 miles per hour or greater. And the reason for that obviously is so that we don't blow some of our cement off of the grade. So here's page 3 of the SP, and I talked about most of those things under item C already. But to talk about this a little more, under item C, it says begin blending immediately after the cement has been spread and continue blending until a uniform cement stabilized base is produced. Now, because this is cement and it's going to hydrate and it's going to set up, we do have a limited amount of time we can work with this. And on the next page, it'll talk about that. That time is 2 hours. But I think the point I'm trying to make here is you just want to keep everything tight. Once you place that cement on the grade, you want to, all the operations behind that, you really want to keep tight. And another important thing is that next line, it says add water to the blended material so that the moisture content is within 2 percentage points of the optimum mix design moisture content. You know, that's really important. If you, that's what the design's based off of. And everything. And if you're not right around optimum moisture content, you're not going to get the correct amount of hydration, or you're really not comparing apples to apples anymore because the moisture content is so different. So on this particular page of the SP, those are the 2 big things I take out of it is keeping everything tight in the operation and making sure that you know where your moisture content is, so that you make sure that it's all being blended right around the optimum amount of moisture. So so with that said, here's a picture of a I'll call it a tight operation. Now, I don't know that you'll see it this tight in the field, but you can see you've got the water truck, the blending machine, the sheep's foot roller, and the blade all pretty much running into each other. I don't know if you need to keep it that tight, but the point is you really want to keep it in that short window. Page 4 of the SP, and this is where it talks about the 2-hour window. Keep the surface moist by using a spray device. Complete all operations with 2 hours of application of cement. So there's the 2-hour window I was talking about. And the next thing in this SP, it talks about wet curing. So once the cement's been added, it's been blended, compacted, and shaped, we want to wet cure this to make sure that we don't lose any water to evaporation or whatever. And you do that by a couple different ways. You can either water spray on. Of course, you don't want to erode anything, so it's a light water spray. Or the other thing you can do is you can shoot a prime coat on it to seal that top and make sure that no water evaporates out of your base. The next thing the SP talks about is micro cracking. So we want to begin micro cracking between 48 and 120 hours of finishing the cement table stabilized base. And how we do this is we use a 12-ton steel wheel vibratory roller traveling at 2 miles per hour and vibrating at max amplitude. Now, this is something I think that our materials and research has done some different studies on this, as far as rolling patterns and testing and all kinds of different things. And this is essentially where we're at right now, is we think this gives us the best micro cracking is to use this weight of roller, this speed at max amplitude. So micro cracking, what is micro cracking? Micro cracking involves passing over a newly constructed cement treated base with a heavy roller to induce a network of hairline cracks throughout the layer. The picture on the left here, that's what that guy's doing, is he's micro cracking the base. The goal of micro cracking, the reason we do it, is to form those fine cracks in there to prevent the wider, more severe cracks from forming, which you can see in the picture on the left. Here's another picture of it. It's essentially block cracking is what happens if you don't micro crack it. Block cracking, it looks terrible, but the other thing it does is it allows water to get into our pavements, which over time obviously accelerates our deterioration of our pavements. Micro cracking reduces the severity of shrinkage cracking. Both the width and the lengths of these cracks are reduced when you micro crack. So that's kind of to talk shortly about stuff that we list in our SP. The one thing I haven't touched on our SP yet is traffic. And I'll talk about that right now for a little bit. So it talks about allowing traffic on the base. You have to let it cure for 4 hours and stuff like that in the SP. Now, different projects may be different. In our particular case, so this is the scope of work for the project in our district, which happens to be on Highway 73, which is east of Wofford City, probably 25 or 30 miles. We're actually not going to allow through traffic on our road because we have 2 box culverts that we're actually going to replace. So we're going to shut traffic down on the highway, which I think will just help us, so to speak, as far as dealing with traffic out there. But anyway, this is an overview of our project. We have both a fold up reclamation on here and also some reconstruction. So I'll just talk about a little bit how we're going to handle it and what's going to happen on our project. So what we're going to do is, first thing is we're going to come out here. We're going to keep traffic where it's at, do our widening on both sides of the road. Once our widening's done, we're going to move traffic to one side. And we are going to come in, add our virgin class 5 on top of the road, as you can see in the second picture down there. And then we're going to come in and do our FDR. We're going to do our full depth reclamation on that side of the road, and then going to spread it out to get our whole section. And once we're done with the right side of the road, we're going to move traffic over there, and we're going to do the same on the left side. We're going to add our aggregate on top, do our blending, shape it. But when we're done with that, that's when our cement stabilizer is going to come into play. We're going to come in and go through the process we just talked about in the SP, where we're going to add cement to the top, blend it, compact it, shape it, and then we're actually going to put 2 lifts of asphalt on it while we have that lane closed. And then we will move traffic back over to the left and do the same on the right side. And then once both sides are done, we will open it up to traffic and put our final wear surface on. So that's for the full depth reclamation area. We also have some reconstruction areas on this project. It's essentially going to be the same process. The only difference being we're not doing full depth reclamation. We're just going to reconstruct it. We're going to remove the existing materials, do probably some subgrade work, and then bring it back on like we did in the full depth reclamation process. So that's kind of a quick overview of what we're doing on our project out here. I don't know if your guys' projects will be the same, if you have full depth reclamation on it or not, but that's what we're going to do in our project. That's kind of an overview of the process, just looking at our SP. And what I've got next is I found a video on the internet that kind of shows the process from beginning to end. Now it's going to differ a little bit with our SP, but I just kind of wanted to show this to give you an idea and to see it in action.
It's an asphalt recycling process where the full flexible pavement section and a portion of the underlying materials are uniformly pulverized in place, then stabilized with Portland cement. The result is a cement stabilized base course, using all existing materials to create a much stronger, stiffer, and more durable section for the new pavement or surface layer. FDR is a cost-effective, fast, and more environmentally friendly alternative to total reconstruction. FDR is how Mount Carmel Stabilization Group began in 1949, and today we do over 100 miles per year. This roadway is exhibiting common base failure, with alligator cracking, full-depth patches, edge failures, etc. The city of Louisville, Kentucky elected to use full-depth reclamation to rebuild this road because it was superior to patching and far more cost-effective than total reconstruction. This roadway is a great example of FDR because no materials left the roadway during construction. The first step in the FDR process is to pulverize the existing asphalt base and a portion of the subgrade in place to create a homogeneous material. On this project, the treatment depth was 8 inches. Depending on the project, treatment depths from 6 inches to 16 inches are common. During this phase, the mixer is pulverizing the full depth of treatment. The gradation of the pulverized material is important during this phase. Typical specifications are 100% less than 2 inches. It is during the pulverization phase that any widening and reshaping takes place. This is important to have completed prior to the beginning of stabilization. Widening is easily accomplished during pulverization if the existing roadway platform includes a shoulder on either or both sides of the road. After pulverizing, the material is graded and sealed prior to stabilization. Phase 2. Stabilization with cement begins. The first step in stabilization is the application of cement on the grade. Cement is spread at the prescribed application rate, taking into account the new composite soil weight. On this project, the cement application rate was 6%. Treatment with with water being added through the mixing drum to hydrate the cement and bring the mixture to optimum moisture content. Immediately behind the mixing process, the process continues with compaction and initial grading. Compaction is accomplished with a vibratory pad foot roller, followed by finish grading and sealing with a steel wheel roller to provide the finished stabilized base surface. At this point, the roadway is completely open to light vehicular traffic. Heavy load should remain off the road for 5 to 7 days to allow the cement stabilized layer to cure. It is also common to shoot a bituminous tack coat on the roadway to seal the surface prior to paving. You are viewing the finished product with a 2-inch asphalt pavement directly over the cement stabilized FBR layer. The city of Louisville chose to leave a 1-foot stabilized shoulder for edge control for the new pavement. The entire FBR process on this 1-mile roadway took only 2 days. Add 1 day of paving, and to reconstruct this road with FBR took a total of only 3 days. Utilizing all existing materials, FBR is the most economical process available for recycling failing pavements today.
So that's just kind of a video of the process start to finish. One other thing I want to talk about, because we ran into it here a couple of years ago. So I mentioned earlier that we had a cement treated base project, 2008 or 2009. When we came in a few years back and replaced the bridge on that section of road, we had to, remove the material at the ends of the bridges to tie into it. And I couldn't find any data on the mix design or what we had for cement content on that particular road. But when we went to take it out, this is what it looked like. It came out in chunks like cement or like concrete. Obviously we couldn't use this material for building embankment or anything like that. So I just bring this up so that you're aware of it in case you ever have to go into a project that has been cement treated. If you have to tie into it or remove it, just know that this is a possibility. So with that, I just want to talk about some of the key points that I think are key when it comes to cement treated base. And the things I guess that I'll be looking for this summer on our project is the first thing when they go to do their mix design. I just want to make sure that the sample that they use is the most representative of what we find in the field. And the other thing I think that is key is moisture content, whether that's in the mix design process or the blending process on the road. Making sure that moisture content is at or near optimum, I think, is really important. And the last thing is to just making sure that you keep that entire operation short, close together, because you have a short window to get all this work completed. So with that, I guess I'll open up any questions or comments.
Yeah, the one comment I would have, Bill, I know some districts, I think when we were talking about this, earlier about what topics to do, that some of them are going to be doing their first cement stabilization job. And one of the things that we did for checking the how much cement is getting applied to the road, I mean, obviously we do spreads just like you would on a chip seal with the cement trucks, so you're getting a large spread and know how far, a trailer load of cement should go. But we also took like a tarp or a thin cookie sheet or whatever and would lay that on the road. And then after the cement powder gets applied on the road, then you can pick that up and weigh that. So maybe if you had a 1 or a 3x3 tarp or something like that you can lay on the road, then you can pick that up and weigh that cement and know kind of what your application rate is. So that was just one comment I had, Bill.
Sure, thank you.
Bill, Kurt Dunn here.
Yeah,
I was wondering, so during the first pulverization process there, is that the time they would grab material for like a mix design?
I think that would probably be the best time to do it, but that'll all depend on, the contractor's schedule and their operation. In our particular case where we have the FDR in front of our cement stabilization, we'll have time to do that. So to answer your question, yes, I think so. And I suspect that's what we'll do on our job, because it'll be a while before they get to the cement stabilized.
Okay, thanks, Bill.
Yep.
Bill, did you after the grinding of the cement and the installation, did you go back through, did you crown check it, or did you use grade control, or what'd you do for slope?
Yeah, either or. I mean, a lot of the blades will have, they'll put the crown in with their blade, but yeah, we spot check it behind that.
Question for you is, when they were watering to keep the cement treated not drying out after everything was done, did they use their normal water trucks, or did they have a special sprayer in the back so that it didn't pock up the top, or how did they do that?
They just used a water truck and drove on the side actually and kind of shot it out from the side of the truck. Is what I've seen up here in the past. And I don't know, Jason, if you guys saw it different down on your project, but the last job we had up here has been probably 15 years ago. So it's been a while, but that's what I recall, is them just using a water truck.
Bill, we've done several FDR jobs, and I guess the biggest thing that I've noticed in the past with all of our jobs is the watering is the most crucial part. I know your video it said that they could, put the prime down or your oil right away, within X amount of time. But what we found is when they come in and they do the cement with the machine, they like to try to do it drier than actual. So like I agree with you, moisture is very crucial. But what we found out that is we actually had to hydrate that roadway quite a bit afterwards, because otherwise, if we didn't, we actually ran into pockets where it actually did not absorb down, and we actually had dry spots of cement.
Okay. Well, that's good to know.
Yeah, I guess just seeing how dry your aggregate is, like in the case of a box culvert, they come in with, whatever, 3-4% moisture aggregate, and then try to get it wet by flooding it. You do the calculation of how many gallons or pounds of water you need to get from their 4% class 5 to their 7 or 8% optimum. It's a lot of gallons. And so to try to get that, it's not something that the contractor's aware of, that they need to, do that many applications or use that much water to get from 4% to 8% without turning it into a mess on top and dry on the bottom. And that's something to pay attention to, just in the case of, a lift of backfill of dry gravel on a box culvert, let alone a cement treated, get that ready to prep or get it prepped to blend.
Yeah. Who all has a cement treated base job this year? I think Grand Forks has one and Devil's Lake have one as well.
The one in Devil's
I might
Lake
be.
got pushed to next year.
Okay. Okay.
Yeah, we have one on 32 from Highway 5 to Walhalla.
Okay.
Be consultant administered.
Bismarck District has one as well.
Okay. Yeah, ours was actually bid in 22, but it was a 2-year project and they didn't do it last year, so they're doing it this year. So we'll see. Haven't seen it yet.